Hey everybody. Okay, so in kinematics, a common occurrence of constant acceleration is when an object is subject to the acceleration of gravity. So if it's in free fall. And we have to make some assumptions, like you're at mid-latitudes, near sea level, and we have to ignore things like air resistance. Then in that case, we can say the acceleration due to gravity is constant. And it's constant vertically down toward, let's also assume that the Earth is flat. Uh, and then it is a constant 9.81 meters per second squared, which we just call small letter g. Okay, so that small g represents this value. It's never negative, right? Like you don't say pi. Is it 3.14159 or is it negative 3? It's always positive, right? So the letter small g means positive 9.81. Of course, the acceleration itself can be positive or negative depending on your choice of coordinates. That's something else. Right? So let's say something is in free fall, so it's falling like this, and then it's going 9.81 meters per second squared. Is the acceleration positive or negative? Depends. Like if I pick coordinates like this, then the x component of acceleration is 0. The y component of acceleration is, right, if y goes up, that's going in the negative y direction, so this would be negative g. Right? Let's say, right, something's falling, but maybe I pick coordinates that look like this. Right? So now acceleration in the x direction would be positive g, right? And then in the y direction, 0. So the acceleration depends on your coordinates. The number, that's always 9.81 meters per second squared. Okay, let's try an example just for practice. So let's say you, like, this is the limits of my artistic ability. So let's say you just drank a smoothie with a paper straw and you're gonna like chuck it in the recycling bin, but you like throw the straw up in the air, right? And then it falls down over here. I hate those paper straws. Like, it's better to use a metal straw, except I'm scared I'm gonna chip my teeth. So I usually just have one of those floppy silicone straws. And also, like, all the paper straws in the world isn't gonna make as much of a difference as like voting for an elected official that sets good environmental policies. Okay, getting off track. Okay, back to physics. So let's say I make up numbers, like this is given, like some height, 1.5 meters, and you throw the straw up in the air and it's going 2 meters per second. Okay, some questions. How high does it go? Like, what's the maximum height? Like, right, it goes up in the air and then falls back down. How high is this at max? Let me move my picture a little bit. Okay, like how high does it go? Okay, let's practice. So let's pick a coordinate system first. So it kind of depends. Let's say vertical is y. So of all the formulas you know in the world, what applies here? This is kinematics for constant acceleration because gravity is constant. So then we can say, and then if this is y, then we know things like and then velocity. And you could combine these two equations, right? And then you have something like this. Okay, let me copy this so I can use it again later. Okay. Okay, so we did that. Now we figure out what is known and what is unknown. Okay, so we're trying to find the max height. So that's some like this kind of value, right? And then let's say, let me draw my coordinates a little bit. I'll put the origin here. There you go. Okay, so the initial position is 1.5. So I know this, right? That's 1.5. I know this. The max height, I don't know. Okay, how long does it take in time? I don't know. I don't know time. Okay, initial velocity, 2 meters per second. Got it. So I know this. The acceleration, AY, is it g or negative g? Y is going up, g goes down, so AY is negative g, right? So I know this. I know this. The maximum height, maybe think about it, like something goes up in the air and then it falls back down. At the maximum height, what's the velocity? Right at that instant is 0, right? Because it goes up, it goes up. At that instant at the top, it's going 0 meters per second and then it falls back down, right? So at the maximum height, this is 0. This is 0. Okay, and then you take a look at what do you know and what do you not know. So of these three formulas, which would you want to use to solve, right? This has two unknowns, this has time, but I don't really care about it. So you could solve this for time and plug it in here and get the answer. That's one way, that's totally right. Or you can just use this, right? And then we got our answer. Right, just like shuffle things over to the other side. So 0, and then AY is negative g, right? Not always for this choice of coordinates. And then that y I'll just call h, right? So then just solve for this. Just, right? Oh, let me just finish it right here like this. And then just move 2g over here. And there you go. Okay, let's maybe make up another. How about okay, so let's say new question. You throw your paper straw up in the air. How long does it take for it to hit the bottom of the recycling bin? So the time. Right, so then step one, all the formulas in the world, you know these. Now let's figure out what is unknown. So that we know the initial height, 1.5. The final, it's going to land on the bottom of the bin, right where this is the origin here. So this will be 0. And then the acceleration, I know it, negative g. So this is unknown. We don't know time. The speed, initial velocity, know it. Final, we don't know, we don't know. And okay, that's everything. So if you look at the three formulas and then what is yet unknown, which do you want to solve? Right? I will pick this one, right? Let me write it down. So right, just solve equation 1, and then that's it. And then let's make up another question. How fast is it going, like the instant before it hits the ground? I mean, after it hits the bottom of the bin, it's going 0 meters per second, right? But the instant before, right, then you look at your formulas. So, okay, I actually can solve for time and then plug it in here, and then I'll know the speed. Or I could just use this formula because I know all the other stuff, right? This is 2, that's negative g, that's 1.5. Okay, so focus on the strategy. The strategy is what's important, right? Figure out what formulas you know, and then really like underline or circle your unknowns. Okay, I'll see you on the next video.